last section of 4.4 is talk about building quadratic models from data. So now let's look at this true scatter data diagram. Just like a linear function data diagram, we call a scatter data diagram. It won't form exactly, the parabola, but we're looking for the data band. Okay, as long as the data band is kind of have a parabola shape, and then we say the data is quadratic data. All right, so like this data band is look like a parabola with leading coefficient a greater than 0, right? Parabola open upward. And then this data band looks like a parabola open downward, right? Open down. So leading coefficient a is less than 0. So now let's look at an example how to fit in a quadratic function to data. And the data in table 8, which is on the next slide, okay, represent percentage D of the population that is divorced for various ages, X, in 2012. And then we would like to do the following, okay, A, B, C, D, E, 5 parts. First, draw a scatter diagram of the data and treating age as independent variable and comments on the type of relation that may exist between age and the percentage of the population divorced. B, using graphing utility to find the quadratic functions of best fit that models the relation between age and the percentage of population divorced. C, use the model found in part B to approximate the age at which the percentage of the population divorced is greatest. D, use the model found in part B to approximate the highest percentage of the population that is divorced. And the last one, use graphing utility to draw the quadratic function of best fit on the scattered diagram. All right, and then we're gonna do one by one. Okay, so first draw a scatter diagram of data. All right, this is the data set, and I actually get this data set from the textbook, okay, page 307. And then now we, of course, you can graph it by hand, okay, but graphing by hand will not be accurate. So I'm gonna use graphic calculator, okay, to graph the scatter data diagram like we did before. All right, so now got a new window, okay, press stat, call the statistic function, and then press edit. All right, so this is the last time data. I need to clear it. So move the cursor to the column name and then press clear. Okay, well, move the cursor down and then the data already cleared. So do the same thing, clear and then move the cursor down. All right, now I'm gonna enter the table, okay, for all the X, the L1, I put all the X, which is the age. And then L2, I put a percentage divorced. Okay, so first data is 22, and then 27, and then 32. I'm gonna enter all the X one time, and then enter all the D. Okay, percentage divorced. 37, 42, 50, 60, 70, 80. Okay, let's double check, make sure all the data accurate, okay, entered into the calculator. 22, 27, 32, 37, 42, 50, 60, 70, 80. Yeah, that's correct. Now move to the column 2, okay, L2. Now enter all the percentage divorced. First one, 0.9, 3.6, and then 7.4, next one 10.4, and then 12.7, 15.7, 16.2, 13.1, the last one 6.5. Okay, let's double check the value. Make sure all the data enter accurately. 0.9, 3.6, 7.4, 10.4, 1. Oh, it should be 12.7. See, this one I got it wrong. I'm sorry. 12.7. Okay, and then 15.7, 16.2, 13.1, 6.5. All right, so now all the data enter correctly. Okay, and then I'm gonna do the scatter plot. All right. So let me see, make sure the scatter plot turned on. Okay, it's already on. All right, and then hit a graph, and it doesn't see anything, need to zoom. Okay, option 9, zoom stats. So this is the scatter plot for the data we just entered. Okay, so based on the shape, we can see the data look like this is a parabola, right, and an open downward. So for the question A, right, we already draw the scatter diagram on the data, and then treating age, right, x-axis is the age as independent variable, and then the type of relation looks like the divorce percentage, right, the percentage of the population divorce is what, and the and the age, they have a quadratic relationship, right? Graphing is parabola. That means the model between x, which is the age, and the percentage of population divorced, right? Relationship between those two variables are quadratic relationship, quadratic model relationship. All right. So since it's a quadratic relationship, and then the part B, use graphing utility to find the quadratic function of best fit model, okay, or best fit data. And then very similar as we do the linear regression, there is a function called a quadratic regression. Okay, it's also under stat, and then also over the calculate, and then option number 5, quad reg, that refers to quadratic regression. Okay, we press option 5 and then go through all those default until we hit calculate. Okay, so here shows quadratic function written in standard form, y equals ax squared plus bx plus c, and then a, b, c value. Okay, that's the 3 coefficient. If we keep 3 decimals, a approximately equals negative 0.0143, right? And then b equals 1.5861, right? Keep 4 decimal. So set a backdoor here, and then 5 is at the backdoor, so add a 1 in the previous digit. Okay, so 1.5861. And then C equals negative 28.186, right? Backdoor is set here, 5, add a 1 in the previous digit. So that's negative 28.1886. All right, so now we can have quadratic function, which is d of x equals negative 0.0143 x squared, right? Plug in a, b, c value, x squared plus 1.5861 x minus 28.1886. That is the quadratic function best match the data we entered. All right, so this is the part B. All right, part C, use the model found in part B to approximate the age at which the percentage of the population divorce is greatest. So it's looking for the X make the Y, right? The percentage divorce greatest. That means we're looking for the vertex of the parabola. Okay, find the vertex, which is use netted B over 2A, right? Netted B over 2A. So that's netted B. B equals 1.5861 divided by 2 times A. A equals negative 0.0143. And then you put this expression into your calculator, and approximately we got X equals 55 years, okay, which is at age 55, and then the population have the greatest percentage divorced. Okay, that's a part C. So that's looking for the X coordinates of the vertex. And then part D is asking for the Y coordinates of vertex. Okay, what is the greatest percentage divorced? So we plug in X by 55, okay, into the quadratic equation, and then we got approximately 15.8%, okay? Just evaluate function when X equals 55. All right, so according to the model we identified in part B, and 55 years old have the highest percentage divorced, which is 15.8%. All right, and then the last part, we want to enter the quadratic function into the calculator. Okay, so let me get a calculator. I need to enter the function, quadratic function here, okay, which is negative 0.0143 x squared, right? X squared, and then plus 1.5861 x, and then minus 28.1886. All right, and then graph. Okay, so you see the parabola almost through all those data, right? So those data are very close to the parabola, which is the scattered data fit the model we found, okay, pretty well. Okay, so that's how we do the use quadratic regression function, okay, to build a quadratic model from the data. I think this is the last slides. Okay, we finished 4.4 today.